Good morning, guys. I finally got my sound working. I'm such a computer genius. Anyway, but today we're going to be dealing with reflections. Again, I meant to post this for you guys on Friday, but it's Saturday now. I'm recording it. I'm just going to post it Monday morning. But I just want to say, make sure you guys have paper and like pen out. You guys should be taking some notes on the different rules. There's quite a few different rules when we get to the reflections. This first slide just has a few problems for you to just review on the translations, what you should know. So give these a try. Pause the video. Try them for a few seconds before you look at the end. Um, so for the first one here, it's a translation and it's -7, 2. So not that you need to write this out, but this would mean you're going to the left 7 because it's for the y value. Oopsie daisy. Don't want to do that. Sorry. I need to click on a pen. You want to go to the left 7 here, and then you're going to go up 2. So if you're looking at this, it's just going to be 4 minus 7. So that should be, and just so we get in the habit, this will be a prime. So this will be -3, and then -7 plus 2 would be -5. All right, now this one is giving you the pre-image and the image. Remember, the pre-image is the original, the image is the new one, and it's asking you what's a translation vector. I'm going to write it both ways just so, again, you get comfortable both ways, but I'm going from -3 to 2. So there's two ways you can do this. Some of us can just do that mental math. If you have an issue with that, if that's not like immediately obvious, this is what you would be doing. You would do -3 plus something that we don't know, and it has to give me 2. -3 plus basically what the vector is, we don't know, um, plus some unknown, and then it's got to be 2. And then we would basically just solve this equation. You would add 3 here, and you would end up with x equals 5. And that's what's happening there. It's plus 5. Then we would do the same thing for the y. Again, some of us can just do it mentally. If you need to do the equation, it'll be -5 plus some y value is equal to -7. And then we solve that. Add the 5 because it's a negative. We do the opposite. And we end up with x is negative. I'm sorry, y is -2. But again, you want to make sure when it's negative, you put the minus. And that would be the vector. If you wrote it the other way, it would be x plus 5, y minus 2. All right, and then the last example, we didn't do one like this, but I just want to, I think it was one or two on the worksheet I posted on Thursday, but we didn't do one, I didn't do one on the video, so I just want to go through how to do this. So let's see how to do it. All right, so my triangles graph, now I just wanted to take a second to do that so I wouldn't waste time. Now, you could do this two ways. You could do the two separate translations and then figure out what the coordinates are by using the graph, or you can just add the two vectors together. So if I just added these together, I would get a vector of +3, and then -5 plus 2 is also +3. So instead of me going 2 to the left, 5 up, 1, 2, 1, 2, 3, 4, 5, and then doing another translation of 5 to the right and 2 down, I can just go 3, 3. And again, I'll just do it for A, not all of them, but this would have been the A after going 2 to the left, 5 up. Then I would have went 1, 2, 3, 4, 5 to the right and 2 down. And this would have been where the final A was. And that would have been the same as me just going 3 to the right and up 3. So instead of doing like two separate translations here, we could save ourselves the time by just doing it once if we added the vectors in the beginning. So now it would be again 3, 3. So this is my A prime, 3, 3. This is my C prime, and 3, 3, B prime. And again, I would just want to make sure when you're doing your graphs, again, unfortunately, given the climate right now, you probably won't have as many graphs to do yourself just because, I know freehanding graphs is a little annoying, but I'll probably only give you guys like one of each graph, but that's the way it would end up looking. And my coordinates would be for A, that looks like 5, 5. And you could just do the addition as well first if you wanted to, and then plot the points. That's always an option. B, it's going to be 6, -2. Now I'm just doing the addition. And then for C, it's going to be 2, 3. All right, so I'm going to go ahead to the next slide and start the reflections. All right, so for reflections, this is our next type of transformation. And when it comes to transformation, I'm sorry, when it comes to the reflection, it's essentially a flip. So if you think about a reflection, it's like, excuse me, you just taking something and flipping it directly over a line. And the line obviously would be established in the beginning. The thing you do need to note with reflections that is different from translations and all the other transformations. This is the only one that reverses orientation. And this might sound a little confusing here, but it says what I meant by this: what's first is last, what's left is right, what's up is down. It'll be a little clearer if you look down below, and we'll do these couple of just visual quick reflections. So if we looked at this word fast, if we were reflecting it, so I'm going to do it over the y-axis here. If I reflected this over the y-axis, it would now be the T, then the S, excuse me, that was it. Then the S, okay, that's a little better. Then the A, and then the F. So what was first, as far as the F, is now the last letter, and what was facing to the right is now facing left. Actually, my F should be the other way. Sorry about that. Thought I flipped it. Ooh. But it should look like this, sorry. A. And my F should be like that. So what was facing to the right is now facing to the left, now that it's correct, etc. So that's what I mean by this. It reverses orientation. To go further with that, with this arrow here, it was facing up, but if I reflect it over the x-axis, now it's going to be, I'm sorry, it was facing down. If I reflect it over the x-axis, now it's facing up. So that's what we mean by reverse orientation. Excuse me, if I reflected this downward, this would be upside down. So that's pretty much what we mean by reversing orientation. And then the other thing here is they're isometric. Again, we spoke about that term with the translations. Isometric meaning that your pre-image and your image are congruent. They should be the same size. Angles are the same measures. Size are the same, etc. So no size change there. Again, the only one of these that is not isometric is going to be the dilation. And just like with the translations, we're going to use the prime notation. No need to worry about the last one. You guys can give that a try. Next slide. So basically, when we are doing the reflections, we're essentially going to be doing them, and there's going to be like rules that need to be applied. This is going to be the first reflection is going to be over the x-axis. I'm just confused. I don't know why this is on the slide already. I had it timed to come up differently, but whatever. When it comes to this, for the reflection, if it's over the x-axis, the rule is the following. If the original coordinates are x and y, when you're reflecting something over the x-axis, the x stays the same, and the y, by being a negative, this doesn't mean that it has to be negative. It's just indicating that the sign is changing. So if it was a positive 2, it would become a negative 2. If it's a negative 2, it'll become a positive 2. Okay, that's what it means by the negative there. And this should kind of make sense if we just think about it. Let me just do a little sketch here. Excuse me. This is my x-axis. It's the horizontal axis. And if I had a point up here, okay, let's say this is like a 1, 3 or something. If this is my point originally, 1, 3, and I'm reflecting this point over the x-axis, it's going to go from up here to down here now. So it should make sense that the x value is going to change signs because now it's going to be 1, but it's going to go down here and it's going to be a negative 3. So that's the rule. So again, you should be writing these down. So there's a couple of rules you need to get today. So basically, we're just going to practice applying the rule, no graphs, for the first couple of examples here. It says, what is the image of A at the reflection in the x-axis? So again, we're going to say it's A prime. And if it's a reflection, this is the verbiage they use. I normally say over, but in most of the geometry, like word problems and stuff like that, it will say in the x-axis. So for this, the 4 stays the same. And then again, the y value changes sign. So it'll be 4, 7. For B, the second example here, B prime, if we're reflecting over the x-axis, again, the x stays the same. and the y changes sign. So it's like the opposite. X-axis, y changes. And then the last one, it'll be c prime, and c prime will become -2, -5. I'm sorry, +5. All right. And just to clarify again, the first value, that again, because there's no negative here, etc., that doesn't mean it has to be positive. It just means it's unaffected. It stays whatever it was originally. All right. So let's try this first example here with the graph. Take a second, graph it, and then I'll unpause the video. Okay, so this is how your graph should look. Hopefully you are, again, at least attempting a couple of the graphs. And if you note here at the top of the slide, I wrote apply the rule first, then plot the points. I wouldn't try to like count this out or whatever. I would just simply apply the rule. The rule is going to just change the y values, the sign. So my a prime is going to be 2, -2. My b prime is going to be 5. And -1, 0. If 0 has no sign, you better not write a -0. If you write a -0, I'm taking off 100 points off your quiz. That'll drive me crazy, guys. So again, do not put a -0, please. It'll make me delusional. All right, so here we go. So if we're flipping over the x-axis, so now I'm going to plot these new points, and it's going to be 2, -2. And that's my a prime. Oh my gosh. A prime, 3, 5. It's my B prime, and -1, 0. C is the same. Now, when the point is the same, you just want to put C, just put a prime there as well. So C is C prime, it's both. And then just connect your shape here. And again, just like we did with the translations, any of the images, you want to just shade it in. All right, let's move on to the next one. So for the next one, I already graphed it here, so we wouldn't have to waste time on waiting for me to plot points. And we're going to reflect over the x-axis. So you guys just give this one a try. At least, practice listing out the new coordinates if you don't take the time to graph it. All right, so hopefully you guys gave it a try. These are the coordinates, and that's the way your graph should look. Probably a little better than mine, but that's what we got. All right, so going ahead to the next slide. All right, so on the next slide, we're going to be doing a reflection over the y-axis. So again, if we have our axes, our y-axis is our vertical axis, so we're going to be flipping over that. Again, I would write down the rule. The rule is going to be that when you're reflecting over the y-axis, if your original point was xy, it's now going to be -xy. So again, if we're just thinking about it, if we had a point over here, to my point A, and I'm reflecting it over the x-axis, I know it's now going to be over here as my a prime. And again, if it was over here and it was like 2, 2, now it's going to be -2, 2, because it's on the other side. So it should make sense that my x's are changing signs. So again, y-axis, x changes, x-axis, y changes sign. So again, and this just means that it changes sign. Doesn't have to be negative. That's not what it means. It just means there's a sign change. So I'm going to list out these new coordinates, a prime, b prime, c prime. You guys give it a try, pause the video. You should be doing that to try to do these on your own a little bit as well. So this is going to be -2, -3. This is going to be +9, 3. And this is going to be 2, -5. Again, the only thing that's going to change is the x. The y will stay whatever it is. If it's negative, it stays negative. If it's positive, it stays positive. All right, and we'll do the first graph together, and then we can, you guys can try the second graph on your own. All right, so for this first graph here, we plot our points. All right, so my triangle's graphed, and now I'm just going to apply the rule first. Again, like before, makes more sense to apply the rule than just plot the points. So for this one, we're changing our x's, so it's going to be -1, 3, 2, 6, 0. Again, 0. You should not be putting a minus sign or a plus sign in front. It has no value. All right, and now let's see what the new graph will look like. My new A is going to be negative 1, 3. So it's right here. It's my A prime. And my new B is going to be positive 2, 6. So right here. And we connect it. C is still the same, so I should be putting a C prime there. And again, I always shade in the new one. All right, so give the second one a try. Pause your video, let's try it. All right, so that's how my second example should look with my graph and the points. All right, let's go to the next slide. Now, this next slide, in order to understand this rule, you need to understand what this line y equals x is going to be. The line y equals x is this line where you guys might remember your tables from like Algebra 1, but it's basically saying that whatever x is, y is. So 2, 2, 1, 1, 0, 0, negative 1, negative 1, negative 2, negative 2, etc. They have the same value. So what this line is going to look like, it's going to be, I'm going to graph it for real, but it's basically going to be, if you look down, it's going to be this line like going across. So if we actually plotted the points, again, I'm just going to go quickly, do a couple quick points. That's the point, sorry, that's the point 2, 2, 3, 3, 0, 0, negative 1, negative 1. This is that line. So I'm just going to sketch that line in here. Essentially, this is the line y equals x. So it's not my traditional x, y axis, is a little bit different. So when you are reflecting over this line y equals x, again, we want to apply the rule first. So here is the rule. What's going to happen, write this down, is these are just going to switch places, your x and y. Don't change any signs. All you're doing is switching their places. So if they, sorry, if they were negative, they would stay negative. If they're positive, they stay positive. There's no sign changes here, just switch spots. So signs the same. So let's see what's going to happen on these first three examples. Again, we're just going to list the new coordinates. So if we're just following the rule, we have A prime, B prime, and we have C prime. So my A prime would be, switching places, it's now going to be negative 2, 5. The sign goes with it. Next one is going to be 3, negative 9. Just switching spaces. And then for C prime, it would be negative 5, negative 2. All right, so I hope that's clear on how you are going to apply the rule. So now we get down to the graph, and what you want to do, first I would just take a second to graph the original, so everyone do that. So your triangle's graphed, and now we're going to apply the rule. So 0, 0 is still 0, 0. Why aren't you writing? Oh no. Sorry, don't know what I did there. 0, 0. B is going to, I'm sorry, B prime is going to be, switch places, 2, 5. C prime is still going to be 4, 4, even though we're switching the spots because they're still the same number. And essentially, I mean, you should be able to tell anyway because you know that this part of it, where AC is on the line anyway. So you know that that's going to stay. So first you could just put a prime by A and C because they are A prime and C prime. And our new B is going to be the point 2, 5. So that's the only point that changes. And we'll put our B prime there. And this is what this is going to look like. Just this little green triangle there. All right, so try the second one on your own. And just to be clear, when you are graphing these, I always want you to graph the line that you're reflecting over. So you do want to make sure that you know what these lines are going to look like. The y equals x. You just saw a peek of the other slide. Y equals negative x, etc. So this is what that line will look like. So make sure you're always graphing that line on your graph. All right, so if we go to the second one, and again, it can be kind of a sketch. You don't have to like go 0, 0, 1, 1, 2, 2. But, it should look pretty much like the line is going to. If it helps you, just put like a point at the end of 10, 10, negative 10, 10, 0, 0, and then just kind of make it go through there. All right, so this is the line that we're reflecting over, and I'm just going to show you guys the answer now. Okay, so that's how your final answer will look once you graph it. Again, make sure you have the line, make sure you have the original, the new one, make sure everything's labeled, make sure it's shaded in. Next slide. All right, so the next rule and the next line that we'll be reflecting over is going to be when it's y equals negative x. So if you think about what I just mentioned in terms of the line for the previous one, again, y equals x means they're the exact same number. I'm sorry, x equals y equals x, whatever. Same exact thing. If it's negative x, that just means that if x is 3, then y is negative 3. If this is 2, negative 2. 1, negative 1. 0, 0. So we don't have a negative 0. Don't let that happen. And if it was a negative 1, that means it's positive 1. Negative 2, positive 2, etc. So what is this line going to look like? Again, I don't need you to plot a series of points. Just know what it's going to look like. This is going to be this line where we have negative 1, positive 1. We have 0, 0. Positive 1, negative 1, 2, negative 2, etc. So it's going to be essentially the same line as the previous one, just with a negative slope or going in the other direction. That's a bad one. Sorry, I started off on a bad angle there. Oh, sorry. I clicked the eraser. So it would look something like that, the line that you're going to be reflecting over for this one. So I'll just sketch it in on the other graph too. Again, I'm not going to sit there and look for you to plot every single point on this line, but it should be passing through the origin, and it should, essentially look like it's going through like 10, 10, negative 10, 10. All right, so once you have the line down, y equals negative x, let's practice applying the rule. When it's y equals negative x, same idea. They are going to switch places, just like with y equals x, but they're also going to change signs. So in addition to a switch of places, so they switch places and they switch signs, and both switch signs. So they switch places and they switch signs. So let's practice on these top 3 and see if we can apply it properly and get the correct coordinates here. So A prime, B prime, C prime. So my A prime, if I'm switching and switching signs, A prime is going to be, it's going to be 3. I'm sorry, not switching places. It's going to be 7. I normally switch them first. Let me just do it the way I normally do it. I normally switch them first, and I'll go back and change the signs. So it's going to be 7, 3, negative. And then I'll go and switch the signs. So this is now a negative. This is a positive. Doesn't matter how. Do it however you're comfortable. But again, they switch places and signs. Both have to be done. So for B prime, I'm just going to switch places first. And then I'm going to go back and remember to switch the signs. This is a negative. This is a positive. Again, obviously for any positives, you do not need to write the plus sign. That's just because I wrote, the negative there. And then for C prime, it's going to be 5. Oops. It's going to be 5, 2. All right, so that's just practice applying the rule. So let's look at this first example. Again, take a second. You want to always graph the original. Okay, so she's graphed. And now let's apply the rule. Again, apply the rule. I wouldn't be trying to graph it first. So if we apply the rule, we're switching places and signs. So this is pretty much not going to look like a switch because they were the same number, but you got it. And it's a negative 2 and a negative 6. Again, yeah, switch the signs. And this is negative 7 and negative 4. So these should be your, and let's see what the graph looks like. So obviously, again, you should expect just because of what you should expect like something down by something. But you should expect something down here. Something that's over here. Or whatever, you do have the knowledge to know, all right, it's supposed to go here. So just keep that in mind that if you do get an answer that is over here or something, that obviously you go back and double check there's a mistake somewhere. Because if it's supposed to go over this line, it should be on the opposite side of that line. So let's do -2, -2. That's our A prime. B is -2, -6. B prime. And C prime is -7, -4. And there we go. That's what my new one should look like. Took your piece of paper and did it over with reflection, they would like land on top of each other. So that looks about right. All right, so everyone tried the second one here with WXYZ. All right, so that's what mine ends up looking like. And here are my coordinates. All right, so let's go to the next slide. All right, so this is a reflection given a horizontal or vertical line. So these are a little bit different. With these, there isn't like a finite rule because it really depends on which horizontal or vertical line you're given to graph. So I'm just gonna plot my original triangle and then I'll explain this process. For this one, it's pretty much going to be a counting process versus an actual rule to apply. Here's my A, 6, 2, and 4, 7. See. All right, so here we go. My original triangle. All right, so now it says to reflect over the line y equals 2. Now this is going to go back a little bit again to algebra 1 because that's when you were graphing lines. We only touch on them really in geometry for transformations and things like that. But this line y equals 2, when it comes to this line, when it's just one letter and one number, that's when it's one of those special lines. It's either a horizontal line or it's a vertical line. If it's y equals and a number like 7 or something, that's when it's horizontal. If it's like x equals -2, that's when they're vertical. And let me show you what this would look like. So I'm doing this line y equals 2. So I'm going to go to the y-axis to 2. And then it's just going to be this horizontal line passing through 2. And the reason this is the line y equals 2 is because every point on this line, it's a 2 for the y value. This is -1, 2, -3, 2, etc. So this is that line. And to figure out the new coordinates, it's really just going to be a counting process. Again, no real rule to apply. So what you would do, B is on the line. So B prime is going to stay the same point. So we're still going to keep that at 6, 2. When you're reflecting over a line, essentially you're just going to count. That could always have been a method. So if we started here, I'm looking at C. I'm going to try to count how many spaces C is away from the line. So I'm going to count. Here we go. So it's 1, 2, 3, 4, 5 to get to the line. So I'm going to go 1, 2, 3, 4, 5, the other side of the line. And that'll be my C prime. And then I can write the coordinates. It's 4, -3. Then I'll go to A. Here's A. For A, let's choose a different color here so that it stands out a little bit more. So for A, here it is. We're going from A to the line. So A is 1, 2, 3 away from the line. So I go 1, 2, 3 away from the line the other direction. Don't move like where it's lined up at. The X value isn't being affected. It stays the same. So, and this is what letter was affected, A prime. And then we connect those new points. So my new shape is going to be A, B prime, A prime, B prime, and then C prime is down here. So this would be my new figure. And I would shade it in again, always shade in the last one, the new one. And A is, for A prime, is 2, looks like, yeah, 2, 5. Now, again, we don't really have any glorified rules for this because there will be a different rule if it was -5, if it was -3, I'm sorry, -8, if it was 8, if it was 9. So there's no rules for these. The best idea is just to count. All right, so the last one, I'll do this one with you, and this will be it for us today. Actually, I think I have one more slide. Points already plotted, and let's see what this line looks like. X equals -3. Again, if it's X, it's a vertical line. So we go to the X-axis to -3, and it's going to be a vertical line passing through that point. So this is the line that we're reflecting over. Again, that line of reflection should always be part of the graph. And we're just going to count. I'm going to start with W just because it's the first letter here. So for W, you can either start from the line and count or from the point and count. It's up to you. But it's 1, 2, I'll do the humps. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And that's going to be where I put my W prime. The coordinates are -8, 2. All right, I'm going to do it for X. For X, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Ooh, barely fit that one. That's going to be my X prime. So that's -10, 1. All right, next let's do my Y prime. So 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. That'll be my Y prime. So that's going to be -9, -3. And my last point is Z. And for Z, we are 1, 2, 3, 1, 2, 3. So Z prime. And then we can connect all of these points. So it's WX. Sorry, this is a different color. WX. Y. Z. So there we go. Shade it in. And it looks pretty good. Oh, I'm sorry, I didn't write the last coordinate. Z is going to be -6, -4. All right, so let's move on to the last slide. And for this is just a few, just mixed up some different things, using a few of the different rules. I'm not going to, I'll take the time, I'll pause it and give you guys a minute to give it a try. And then I'll just show you what the answers are. Okay, so here are the answers for J prime and M prime. Those are just directly applying the rule, so hopefully you guys are able to do those. Here was the rule for the y-axis, and here's the rule for y equals x. They just switch places, and the x change is fine. But for the other two, you kind of need to do the coordinate plane, so I just put those on the graph. Here's my original point K, here's my original point L. So I'm going to do K first. So K needs to be over the line y equals 3. I'm sorry, x equals 3. So I'm going to do that one in green. So x equals 3. Here's the x-axis. Here's 3. This is the line. It's vertical. And if I'm reflecting over that line, again, I'm going to count 1, 2, 3, 4. 1, 2, 3, 4 the other way. So this is going to be my K prime. So my K prime has coordinates of, this is a -1 and then 4. All right, and let's do the last one. The last one is L. So for L, we're reflecting that over the line y equals 1. So I'm going to do this one in purple. Y equals 1. We go to the y-axis to 1, and we draw a line through it here. Now, hopefully you recognize, even though my line's a little crazy sloppy, that L is on the line. So that is L prime. So it's the same point. It's going to stay for 1. All right, guys, I'm posting some extra practice. Again, do you need to do everything? No, but definitely do some of the practice. That's how you guys, memorize the different rules, and it solidifies the concepts. Alrighty.